welcome everyone. Thanks for being here, for listening. What we are going to talk about today is a bit of a different use case. I'd say a bird of different feather. We'll be talking about texts in the humanities and how XML and processing XML can be used to the advantage of the humanities research. So when I say we, I mean the R&D team at the Huygens Institute for the History of the Netherlands. And we are a very small team working on humanities cases, but applying computational methods and computational research to see how we can promote and advance humanities research. Well, XML plays a big role in the humanities. It's used in literary studies, in history and linguistics. And in this paper, we focus specifically on computational philology, so to speak. Philology is the study of language in written historical sources. And it's a combination of literary criticism, of history, and of linguistics. And the computational part will become clear in a few minutes. Now, in the XML model, scholars in the humanities express their understanding of a text, and they create textual models which can be used for further processing and analysis. And what is so wonderful and interesting about the humanities cases, or the texts you see in the humanities, is that they present really not quite original challenges for XML modeling. It usually doesn't fit in the OCO model. To this goal, there is the TEI, which stands for Text Encoding Initiative, and they develop a set of guidelines that can be applied to, there are basically a lot of different tag sets that scholars can use to express what they think of their text. The guidelines and the tag sets can be customized, so what you end up with basically is a TEI encoding which can be very dense and can contain a lot of scholarly knowledge about that text. In this presentation, we will talk about a specific kind of analysis, which is called collation. And collation is the comparison of two or more text versions. So in that sense, it's quite logical that we are in a slot about diffing, but I hope you will understand that there are some big differences here. Now, these complex texts we end up with, they contain elements that are extremely important for further analysis. So the markup, we want to contain that. And usually in collation, which is a very old, I would say centuries old, scholarly primitive used to compare texts, the focus is on the text. So the automated collation tools also focus on strings of characters. But then you would lose the information in the markup. And, well, that would be a shame, because it's useful information. So, again, what we are looking at are sort of the idiosyncratic tags by TI that express meaning, and that meaning is relevant for further analysis. Now, sorry, I need to use this one. The question we'll be discussing is how can we use the potential of XML for computational philology? And that would entail three things. First of all, we would like to model the textual variation that is expressed in TI. That would mean that we need to process those files. That entails hypergraphs and hypergraph merging. We'll talk about that a little bit later. And finally, visualizing and exporting the results of this comparison. I will show you a number of very small textual fragments so you understand a little bit what we're dealing with. You will be seeing these fragments in different versions. The first type of text is, or the first type of textual phenomena is open variants. It's a bit unclear on the transcription, but there is a line of text, and the writer, Virginia Woolf, has written between, above the word with. And she hasn't crossed out the word with. So that means that there is a variance, but it's open. She hasn't made a decision yet. Now, if we look at a very simple transcription of that text, you can see it can be encoded in TI like this. It doesn't really matter what tags are used in this case. It's just for you to understand that these two words, with and between, are, as you can see here, they're at a lower level in the XML tree. And the way this is processed would mean that if we just focus on the text, on the textual character strings, that these levels are not taken into account, and the fact that that with and between are tagged as an open variant is ignored. And another example, which is interesting as well, is simultaneity, as it can be called. And you can see here that the words on the landing are added, but the word landing is written without the IN. So in a textual transcription, you can add that correction in a core element that is nested within a choice. And you see here the XML tree representation of that textual fragment, that there happens a lot around on the landing. It's the words are in an add element and landing, and the correction is in a choice element. So these words are not on the same level, but what we would want as textual scholars and humanities is that these are treated as on the same level. So there are here two versions within this manuscript text, so to speak. So abort creeks, that would be a baseline version. And then on the landing is a second version of that text. And both of them are equally valid. So if you want to compare this text to a different version, you would like to include abort creeks as it is, and abort creeks on the landing as it is. So you don't want to differentiate between these two internal versions. And I'm going to use the correct term for that. It's called intra-documentary variation. So that's what you see here. It's a kind of variation that happens within one manuscript or humanities text. Now, another type of variation can occur on the structure of a manuscript. You can see that here we have one text version, and in the margin, Virginia Woolf has written 2. And with that 2, she wanted to indicate that actually a new chapter should start here, chapter 2, which becomes more clear if you look at the typescript of the same text, where indeed, but what after all is one night, which is here further, what is one night, is the start sentence of a new chapter. But this chapter number is 3. So you can see that there is, there's a difference between witness 1 and witness 2. Here you see the very simple XML transcription of both witness 1 and witness 2, and the number 2 and the Roman numbering 3 are both tagged with a head element to indicate that they are actually the start of a new chapter. And this is the 3 representation. You can see here again, the 2 is in the head, and that is nested in an add element. And here you see the witness 2. But what is also clear here, you can already do a little bit of the comparison with your eyes, is that this is all one diff element, one p element, and 2 s elements. Here there are 2 diff elements, 2 p elements, and 2 s elements. So the structural difference in this case is kind of important. Were you to compare witness 1 and witness 2 on the level of the plain text only, you would just compare what is now pink. You wouldn't really know that in this witness 1, the 2 was actually significant and indicates a change of structure in the work, in the literary work. And in this case, you would see it, but you would lose that information in the comparison. So I have shown you now 3 examples, which are just a very tiny fragment of the number of textual phenomena, literary and texts in the humanities in general can contain. But I hope that it gives you sort of a small idea of what kind of texts we are dealing with, and that it is important to contain the markup when we start analyzing these texts, that the markup, which contains a sort of scholarly knowledge, the knowledge that the transcriber has, the interpretation of the transcriber, if you will, that is important to keep that. Here you see again that when you start to compare the 2 witnesses, that there's a big difference in structure and that the structure is important. So the interdocumentary variation, you saw an example of the structure also. So if we want to model texts in the humanities for humanities research, we have to go beyond the IACO. We have to include this interdocumentary variation, which entails that one text has actually multiple paths in it. And these paths are encoded with the TI tags. A path can be indicated by an add element, and the add element would indicate the start of a new path, or a del element. And in addition to that, we need to take the structure of these documents into account. So if we want to compare these structures together and we want to store the result, that would mean that if we want to keep the information, we need to store multiple structures in one file. In other words, what are we dealing with? What kind of texts are we dealing with? There are, as you know, different types of XML data. It can be fully ordered. It can be unordered. But what we are dealing with in this case is text-centric or document-centric XML of literary texts. For reasons of brevity, I will refer to that as TI text. And that is partially ordered data. Think about these open variants. The start of a TI add tag indicates that at that point, the text is unordered. But for the rest of the transcription, the text characters are in an order. So you have both order and unordered. So we have partially ordered data. And this partial order is important. It's something we want to keep. If we want to do that, what will we need? If we want to process and analyze TI text in a native way, containing the knowledge that these files have. If you want to process them for analysis, we need to have an automated collation tool that finds the minimum set of changes needed to turn one document into another, whilst taking into account this markup, whilst taking into account the structure and the different variants inside one document, maybe inside another document. So at the outset, we have 3 requirements. The documents are partially ordered. We want to treat text structure and text equally. And ideally, we want to treat more than 2 documents because usually text versions there can be 12, there can be 15, there can be 50. So we don't want to limit to 2. That means that our data model needs to be schema aware. It needs to understand that an add element indicates the start of an open variant. Or a del element, or whatever. It needs to understand what these tags mean, and needs to be able to store these multiple hierarchies in a new file. So in processing terms, it means we want to find the smallest amount of differences between 2 TI texts. We also would like to distinguish between words, between punctuation and markup, because all of these are important in our analysis. And we want to respect this non-linearity of the TI text. So we have created a tool called Hypercollate. It's an automated collation tool, and it contains, it uses a hypergraph model for variation. What is a hypergraph exactly? Perhaps most of you have already heard of it, but I'll be short. As all graphs, it has nodes. It has hyperedges, and these hyperedges can differ. It can have a one-to-one relationship, a one-to-many relationship, or a many-to-many relationship. Here you see a very simple color example of a hypergraph. It's the same text as we used in the example. And you can see, for instance, that TI, which is the bright yellow ellipse, that's one hyperedge. And it had the relationship between TI and the text notice is a 1, the TI element, to many text nodes. But if you look at the core element, which is a one-on-one hyperedge relationship with landing in this case. So Hypercollate, our tool, processes the complex features of text, all these phenomena I just talked about and more. So that includes the overlapping hierarchies, and that includes the interdocumentary variation. Here you see another example of the between and the with, which are both contained by a hyperedge of zeg. So it's a one zeg to many between and with relationship. So how does Hypercollate work exactly? First, it takes every XML transcription, every TI text, and transforms that into a variant hypergraph. This would be a variant hypergraph. Then it would align two variant hypergraphs. So keep in mind the structure example. These two hypergraphs would be aligned. It would merge, after the alignment, the two hypergraphs into one, what we call a collation hypergraph. So that hypergraph contains the result of this comparison. If there are more than two witnesses, which can very well be the case, it repeats this process in these 3 steps. And the final step, the collation hypergraphs, the information it contains needs to be visualized or exported for further information. So, as a very visual illustration of step 1, you can see here the structural example. The upper block is hypergraph, variant hypergraph of witness 1. The lower block is variant hypergraph of witness 2. And you can see again here that the head element, the head hyperedge refers to the 2 and the Roman number 3. Step 2 is these two variant hypergraphs here without colors are aligned. Alignment is visualized here by a small dotted line. So the 2 and the Roman number 3 are aligned because both of them are heads, or do have a head tag. The same goes for the word what, because that's textually similar, or the same. And here you see the collation hypergraph. So this is what it looks like if the 2 are merged. And the lower part is like I blew it up so you can clearly see that the Roman number 3 and the 2 are contained in one head. This is what it would look like if we have the visualization is still something that needs further improvement, because this might seem very complex to you, because that's the case. It is a very complex data structure, but this is not something bad, we figured. What we are dealing with is something really complex. We have an amount of textual witnesses that all contain a lot of information. So if you put them together into one collation hypergraph, obviously it's going to look extremely crowded with information. So a very important part of this is also how are you going to visualize and export this? Perhaps it depends on what you as a user are interested in, what you as a scholar are interested in. But yeah, you can see here the text nodes are in white and the hyper edges are colored. And as in a conclusion, yeah, I hope I was able to make it clear to you that TI text is partially ordered data, and that poses a lot of challenges for processing. But it's important to keep this, to respect this nature of TI text, because the information contained in one transcription is very useful for further analysis. So if we want to focus on textual variation in the analysis, we need to be able to process multiple paths in one witness. That means that whatever processing we use needs to be schema aware. And we want to store the result in a file that is able to contain multiple hierarchies. So that's the second requirement. And by using a hypergraph model for variation, we are able to do both things and more. So in that sense, we are able to use the potential of XML for humanities research most optimally. And this is it for now. I hope it was a bit clear. I hope it was clear, actually. And if you do have any questions, we're very happy to hear them. Thank you.
Thank you very much, Elli and Ronald. It has been a very interesting talk. So, do you have any questions? Achim, over there.
Thank you for this interesting talk. Maybe I skipped it. What is the result of your analysis? How do you showed us the visualization. Is there an XML representation for this result? Or what is the format of the result?
The format is a hypergraph. But as I talked about exporting the results, obviously it would be useful if we can export the hypergraph, information from the hypergraph into an XML document. But that would mean that you would have to scale down the information, because the hypergraph can easily contain a lot of information that would be difficult to model in an XML document. So that's a very interesting thought exercise, actually, to do. What are you interested in as a user? What kind of information do you want to keep? And what information is, for your purposes, not that interesting and doesn't need to be exported to an XML file?
Thank you. There is a question from Michael K.
You used the adjective schema-aware a couple of times, and I'm not sure you used it in the same sense as I use it. I wonder if you can explain what you mean by that phrase and what its significance is.
Okay. What I mean in this case, and I don't know what your interpretation would be, but the schema awareness element is specifically needed because the processing needs to know, or the hypercollate needs to know that an add element means that that's the starting point of a path. So I wish I could draw. Imagine the text as it was written by Virginia Woolf in one linear fashion. Then suddenly she decides, oh, I want to change something. And she crosses out a word and adds a word on top. So you have this text, and then suddenly it splits. This split means that there are two paths. After the revision she made, the text joins together again. So if you are a transcriber, an encoder, a scholar, you could possibly encode this split by using a del element or an add element, or well, it depends on what you want. The hypercollate would need to know that an add element signifies the start of this split. So in that sense, it needs to know what an add means. You just need to be aware of the schema. I hope that answers your question.
Okay, I think so.
Okay.
Thank you. And we have still time for one more question.
There.
Over there, up. Abel or Floran? Abel.
I have to admit, I'm not really, versed in hypergraphs and these things. I believe that's something very mathematical that lies behind that. But when I look at those hypercollations that you were talking about, somehow, if you apply that to a different context, what happens? I mean, you were talking about a specific text here, and you have the chapter 3 and the number 2, and they magically happen to be compared positively. But if I give that to another text, what happens? Or is it simply not, is it not suited for that? Or is that, what am I missing?
I'm not sure if I understand your question.
Okay, take the same thing you've just been talking about with landing and land G, and you use it with another text. Is it meant to be used with alternative text, or is it very specific to be used with only one type of source material?
The source material in this case would be different versions of the same literary work of Virginia Woolf. Because you have to keep in mind the context here is textual research, it's computational philology. So I would be a textual scholar who is interested in mapping the variation between different versions of To the Lighthouse, for instance, of Woolf. So I have a lot of versions of this text that are different in structure and in content. So I think I hope that's what you mean. So I wouldn't just add random texts that have nothing to do with To the Lighthouse to the comparison, because that wouldn't serve my purposes.
Yeah, so after you've done this work for Virginia Woolf and you would want to apply the same to, let's say, Hemingway or something, then you would have to start from scratch, or is this reusable?
Maybe the question is if you have some old book, if you can do it automatically, like tagging in TEI with all those variants, or if someone has to do it like manually. Probably this was question.
Yeah, that's another way of putting it. Thanks.
I think Hypercollate is a tool textual scholars can use to study variation. So they would use it if they want to study variation in Hemingway, and they would apply it to Hemingway's texts. It looks at a variation, a very fine-grained level. So it looks at the differences between texts that are largely similar. If you want to compare texts of Virginia Woolf to the text of Hemingway, then you would not be able to do that.
That's not what I mean. I don't mean to compare Hemingway to Virginia Woolf. I mean to compare different, let's say, different manuscripts from Hemingway to Hemingway.
So what we presented today is a general tool, and it's a general data model. So what the tool does is take the XML, the data that's in the XML file, and transforms it from the tree model into a hypergraph model. And so the code actually does that. So while we're showing specific examples, you can do it with any XML file. It's basically a different processing model. So we take the tree as an input, and then we leave it behind during the processing.
And then I assume at some point you get this fine-grained things like these choices between land G and landing, and that is specific to one certain writer or one certain manuscript.
In the TI transcription of one manuscript or one TypeScript, the editor has marked the tree as a header and the two as an addition and a header. And so I think we have an example of that. Do we have an example of the TI file in this case?
Or maybe next year we can ask Boris to do some excursion into their their institute, and they can show us some old books together with digitalization.
I think I understand. I have my answer. And I may have some additional questions, but I will find you in the lobby.
Okay.
Okay, but anyway, you can continue this discussion in over the coffee break, which will be in 30 minutes, because we still have one talk in ahead before the coffee break. So thank you very much again.